Right, so our first problem here, guys, is we got the 800 kilometers north, and then we have 256 kilometers at 35 degrees west of north. So my first line is just north. Okay, and it's 800 kilometers. And then my second vector is 256, but it's west of north. So I'm going to draw a reference line that's north, and then I'm going to go west of it, 35 degrees, for 256 kilometers. Okay, my diagram's approximately to scale, right? At least good enough that I'll be able to get what I need from it. So that means that my resultant goes from start to finish. Okay, now I'm going to draw the triangle over here, but it is entirely possible that you may have drawn the triangle the other way, and if you did, that's fine. You're just going to get the complementary angle to what I get. Okay, all right, give them a mark if they have a diagram that at least looks somewhat similar to that. All right, next thing we got to do, find x and y for all the vectors. Well, finding x and y for the 800 kilometer vector is easy because it only goes north. Okay, so I'm going to give you one mark for saying that x equals 0 and y equals 800 kilometers north. Okay, that's finding the x's and y's for that vector. All right, we didn't have to do any math for that because none was required. All right, now we got to find x and y for our red vector, our 256 kilometer vector. Now, x is the opposite side, so I'm going to use sine to find it. So x will be the sine of 35 times 256. All right, so 146.8356. Okay, kilometers, and that's west. This is a method mark only. Whether they got the answer for that part right or not, if they have sine of 35 times 256, give them the mark. Okay. If this is just a method mark. Whether they got this number here or not, if they showed this step, they get a mark. Okay. Now, to find y is the adjacent side, so that's going to be the cos of 35 times 256. All right, so we got 200, not cos of 3, cos of 35 times 256. Okay, so 209.7029. Kilometers, and that's north. All right, one mark again for just this part. Okay, just a method mark. All right, now I can find green x and green y simply by adding the x's together and adding the y's together. Well, green x is easy because green x, there's only one x value, okay, and it's 146.8356 kilometers. I'll even be generous and say you can have a mark for that. Okay, for recognizing that's what green x was. Okay, to get green y, we have to add 800 kilometers and red y, okay, which was 209.7029. So that's going to be 1,029 point. Sorry, not 29. Yes, sorry, 1,209. No, what am I saying? 1,009. Holy smoke, I gotta have more coffee. 1,009. Okay, 0.702. Okay, kilometers, and that's north. Okay, this one's west. One mark for that. Should definitely get a mark for that because I couldn't do it. They can still get the method marks, yes. All right, so our next thing here now is we need to use Pythagorean Theorem in order to get the magnitude of our total displacement. All right, so total displacement is going to be 146, okay, with all the decimals squared, plus 1009 squared, okay, obviously with all the decimals there. All right, so we got 146, 146.83. All right, so we're finding here that the total displacement is 1,020 meters. All right, give them a mark for that step. Okay, they show Pythagorean Theorem. I'm good with that. Okay, then we have to find the vector, okay, of our final displacement here. So theta is going to equal 10 to the minus 1 of the two sides I calculated. That'll be 146 divided by 1009. Whoops, I did that backwards. Okay, sorry, it doesn't matter. All right, so our angles are going to be, okay, if you drew the triangle this way, okay, so if you drew the triangle that way, you're going to get an angle of 8.2. I think it was 8.2, right? No, 8.3. Of 8.3 degrees west of north. Okay, if you drew it the way I drew it, okay, then it's going to come out slightly different. Okay, it's going to be the complementary angle, which I'll write in the right way this time. All right, so I'm getting 82 degrees. Okay, just wanted to make sure I was getting the same thing here. Okay, I'm going to get 82 degrees, and that's going to be north of west. All right, our answer can only have two significant figures because the angle only has two significant figures, and we used it to calculate things that helped us arrive at our final answer. So our final answer is going to be, okay, sorry, this is worth a mark here as well, so that should be 7 there, and then this will be our 8th and final mark. Our total displacement will be 1.0 times 10 to the 3 meters, okay, at either 82 degrees north of west or at 8.3 degrees west of north. Okay, that's your 8th and final mark. Questions on that one? Talk to me after. Okay, any other questions on that one, guys? All right. So, watch and listen carefully here, guys. Second one, we've got a vector of 550 kilometers, 41 degrees east of north, and then 333 kilometers at 25 degrees south of west. All right, so our first one is going to be east of north. All right, and it's 41 degrees, so it's like this. Okay, so here's X and Y. Okay, this is going to be our 41 degree angle, 41.0 actually, and this is 550 kilometers. Everybody all right with that? Okay, our second vector is 333 kilometers at 25 degrees south of west. Now, this is tricky because it completely backtracks on itself. What I have to figure out is, does it get past where it started in terms of its X value? Okay, It's hard to tell that kind of just by looking at it. So I'm going to draw my reference line that's west, okay, and get my 333 kilometers. I'm going to say this probably doesn't. That's going to be my prediction. This does not get past where I started. Okay, it's going to end up somewhere in here. All right, so 25 degrees south of west. Here's y, here's x, and this is 333 kilometers, and this is 25 degrees. All right, I think that's at least somewhat to scale. Okay, but south of west and then east of north for the other one. That means that my resultant goes right here. Okay, so I would say probably best to draw its triangle right there. So this is a busy diagram because everything is over top of everything else, and that happens sometimes. Okay, so here's x, here's y. Okay, this is going to be theta in here, and this will be our overall displacement. 1 mark if they got a diagram that looks like that. All right, now we need to find all of our x and y components. So to find black x, this will be worth 1 mark. Black x is the opposite side, so that's going to be sine of 41 times 550. All right, so we got 360.832. And that's going to be kilometers, and it's going to be east. All right, then I got to calculate y. So that's just a method mark, guys. If they have this part here, they're good. Okay, y is going to be the cos of 41 times 550. 1 mark if they did that. Okay, so that's going to be 415.0903. Kilometers, and that's north. All right, then I need to do the same thing for the blue triangle. Okay, so blue x is the adjacent side. So cos of 25 times 333. 1 mark for that. Okay, so rather than kind of laugh at the mistakes you made, maybe pay attention to the solutions. All right, so 301.8. Kilometers, and that's going to be west. All right, and now this is where I confirm that I drew my diagram correctly. My black line went over 360 to the east. My blue line only comes back 301 to the west, which means I did draw it to the right place. It ended up short of where I started on the x-axis. Okay. All right, and then for y, okay, y is the adjacent side, so the sine of 25 times 333. All right, it's 140.7319. Kilometers, and that is going to be south. All right, 1 mark for that. So we're up to 5 marks already. Okay, our next step is to calculate red x and red y. Okay, so red x is going to be our 360 meters east minus our 301 meters west. Okay, so we actually punch in that with all the decimals. 360.832 minus 301.8. Okay, so 2 is, oh, sorry, missed a decimal point there. 360.832 minus 301.8. All right, it's 59.032 kilometers. Okay, and that is going to be east. Okay, 1 mark if they got that. Got to do the same thing with the y's. One is north, the other is south. So I'm going to take the one that's north, that's 415, and subtract the one that's south, 140. And again, obviously using all the decimals when I do that. So 415.0903 minus 140.7319. All right, so 274.3584. kilometers, and that is north. Okay, 1 mark for that. So we're up to, what now? 7? Yeah. Okay, next mark, I got to calculate D. Okay, D will be Pythagorean Theorem again. All right, so that'll be 59 squared plus 274 squared, obviously with all the decimals in there. So okay, so my overall displacement is going to be 280.637 kilometers. Okay, 1 mark for that step. I got to find the angle of that. Okay, so that's going to be tan to the minus 1 of the opposite side, which for me was x. So that'll be 59 over 274. All right, so my angle ends up being 12.14 degrees. Okay, and it's going to be east of north. All right, 1 mark for that, so we're up to 9. Okay, and in our question here, we have how many significant figures? 2. The 25 is only to 2 significant figures. So looking at the numbers I've got here, 280 to 2 significant figures, 2.8 times 10 to the 2 kilometers. Okay, this to 2 significant figures, 12 degrees east of north, or at 78 degrees north of east. Okay, either one of those would be fine for their 10th and final mark on that one. Okay, so give them a mark out of 18. Put it at the top where I can see it, please. Let them see it, and then you can turn them in on the desk here right in front of Jen.